Hey guys, we're going to solve one-step equations today. So solving an equation means to determine the value of the variable that will make the equation true, meaning I plug in this number for x and it makes this sentence true. So an equation has, an algebraic equation has variables, operation symbols, numbers, and an equal sign. The left side expression on the left side is equivalent to the expression on the right side. And so the act of solving this equation is finding the value we could plug in for x that would make this true. Now, not only are we going to be trying to find the solutions, but we're going to be learning to show our work solving solutions. So we're going to be showing the inverse operation happening to both sides of the equation and simplifying vertically. So when I look at this equation, the first thing I need to do is determine what operations being performed to the variable. So I look at this and I see, okay, we're adding 7 to x. Then I want to think, okay, well, what's the opposite of adding 7 to x? So we're going to apply the inverse operation to both sides. The opposite of adding 7 is subtracting 7. So I would subtract 7 from the left side. I'm also going to subtract 7 from the right side. And when we're solving, we're going to keep our equal sign lined up. And I know a lot of students at Carmel Middle School call these railroad tracks. So you can draw your railroad tracks in if you want to keep it all lined up. They don't have to be there. Ultimately, just your equal sign should be lined up. And I'm showing that I'm subtracting 7 on both sides, because if I don't show it on both sides, then I'm writing something that's mathematically incorrect. Because if I only subtract 7 from one side and not the other, then both sides are not equal anymore. So then I'm just kind of combining like terms. When I look at this, I have positive 7 plus negative 7. Well, right, we're adding opposites. That is 0. And all I'm left with on the left side is that x. I'll bring the equal sign down. And then I'm doing the 8.5 minus 7, and I get 1.5. Once I have determined the value of the variable, I am done, but I can always check. So equations are awesome. You can always check if you're right, because you can plug it back in. I can take my original equation and I can substitute this 1.5 in for x. And when I'm plugging it back in, I'm checking. I'm like, does this equal 1.5? And if I do 1.5 plus 7, I do get both sides equaling 8.5. So I know that has worked. I've checked my answer. So I can always check it's right by plugging it back in and seeing if it actually makes both sides of the equation equal to each other. Now, you don't have to show your check. I'm not going to ask you to show your check on your homework or on the test, but it is something you should do. You should check if your answer is right. You should be plugging it back in and making sure it actually is the solution. The next one, I see, okay, I look at what's happening to x. We're subtracting a half from x. The opposite of subtracting a half would be adding a half. So I'm going to add a half to both sides of my equation, and then I'm just combining like terms. If I have negative a half plus a half, that is 0, and I'm just left with that x. I'm kind of bringing that x down. I can bring my equal sign down, and my 5 plus a half gets me 5.5. And I'm just going to mentally check this one. Is 5.5 minus a half equal to 5? Yes. Then the next one. Now, this is a little bit trickier. What's happening to the x? Well, it's a little backwards, but we were adding negative 9 to it. So what's the opposite of adding negative 9? It really is, the opposite would be, the opposite of adding is subtracting, and the opposite of adding negative 9 is subtracting negative 9. So technically, the inverse operation here is subtracting negative 9. However, if I was actually doing this one, I would kind of look at this and I would know, okay, like I'm trying to get x by itself. Like, how am I going to get rid of that negative 9? Like, I'm just going to be adding 9. right? Because is adding 9 the same thing as subtracting -9? Yes. So really this is how I would be showing my work, but I'm going to be getting the same answer either way. Here, that cancels out. I'm just left with that positive x. And I'm really careful to look at the sign in front because it's not always a plus. I'll bring my equal sign down and I'll do that 16 plus 9 and I get 25. Again, here I would see that I have this positive x left. I'd bring my equal sign down and 16 plus 9 would get me that 25. Okay, now this one, I'm looking at what's happening to the variable and I am subtracting -2. We're doing inverse operations, not the opposite number. So the opposite of subtracting would be adding, but I'm still keeping that same number, that number the same. I'm adding -2 to each side. Here, they cancel out. That was the whole point of doing it. I'm just left with that x. I can bring the equal sign down, and then I'm doing -6 plus -2. I would get -8. And I can double check, I can mentally plug this in. Does -8 minus -2 equal -6? Yes. Now, this is kind of confusing sometimes. So the other thing you could do, instead of thinking, okay, the opposite of subtracting -2 is adding -2, I don't love these two signs together. So really, when I'm looking at this, I'm already thinking like, I'm going to rewrite that. Isn't x minus -2 the same thing as x plus 2? And if I simplify this first, then it's easier to see what I need to do, right? What's the opposite of adding 2? I'm going to subtract 2. And then, okay, I have that. Those are opposites. We get 0. I just have x. And then I have the -6 minus 2, or -6 plus -2, and we get that -8. Okay, so you try these 4 before we move on. On the front, we were just adding and subtracting. These back ones are going to be multiplication and division, and we got some fractions in here. I always start with looking at what's happening to the variable. And here, 8 is being multiplied by -8. Sorry, x is being multiplied by -8. I'm always thinking, what's the opposite operation? Not the opposite number, opposite operation. And so the opposite of multiplying is dividing. And so the opposite of multiplying by -8 is to divide by -8. So opposite operation, not the opposite number. I'm still dividing by -8. And it has to be by -8 because what I'm trying to get is I'm trying to get 1x. I want the -8 divided by -8 is going to get me 1, right? That's 1. And so I have 1x, or just x. I can bring the equal sign down, and I have 4 divided by -8. That's going to be a fraction, right? Only half of 8 fits into 4. So this is going to get me -1/2. And I can double check. If I plug this back in, does -8 times -1/2 get me 4, positive 4? Yes, it does. So then this next one, I'm not thinking this is a fraction. That's a division bar. X is being divided by 5. So the opposite of dividing by 5 is to multiply by 5. And multiplication, when I do it to both sides, it's the only one I don't do below. I kind of show it to the side. So I'm going to take this whole side and I'm multiplying by 5. And I'm also multiplying this whole side by 5. And then I can have my 5's cancel here, right? This was actually the multiplicative inverse property, 5 times that 1/5. I'm just going to have this x left over, have the equal sign, and -7 times 5 gets me -35. And mentally check. If I plug this in, -35 divided by 5, is that -7? Yes. Okay, but now I really do have a fraction. And when I have a fraction in front of a variable, it means multiply, right? This is 9/10 times x. So technically, the inverse operation would be to divide by 9/10. But when you divide by a fraction, dividing by a fraction is the same as multiplying by its reciprocal. So dividing by 9/10 is the same thing as multiplying by 10/9. So that's what I'm going to do. If I see a fraction in front, I'm going to take a step ahead. I'm not going to be dividing by 9/10. I'm going to be multiplying by 10/9. So I'm going to multiply by that reciprocal on both sides. And there, you see, we can use this multiplicative inverse property, right? The 10s and the 9s cancel out, and we're just getting 1x, right? Because 10/9 times 9/10 is 1. We have 1x. And then here I can multiply these two fractions. You could go straight across. You could, right, do 3 times 10 to get 30 and the 4 times 9 to get 36. And then you can simplify. This is 5, 6. Or you can cross simplify as you're doing it. 3 goes into 9 3 times. 2 goes into both of these. You could do 2 goes into 2 goes into 4 twice. 2 goes into 5 times. And then you can multiply here, right? 1 times 5 gets you that 5. The 2 times 3 gets you that 6. Or since we're in module 2, we can use our calculators now. And our calculators can do fractions. Oh no, where's the light here? So I can use this calculator, which is not showing up in the light right now. And I have this fraction button, which you guys can't see, but I can literally type in 3 fraction button 4 and then times it by 10 fraction button 9. Sorry, it's not showing up in this light, but this fraction button I'm pressing is this like little ABC one. I'll show you guys in class. And when I press enter, it tells me 5, 6. My calculator does fractions, yay. So we get 5, 6. Okay, last one. I got a mixed number in front. So if it's a mixed number, I can turn it into improper. I can do that like 7 times 2 and then add 1. So 14 plus 1, this is really negative 15 sevenths. So I'm just like rewriting. I'm just going to rewrite this problem. I wrote it as an improper. If it's an improper, now to get rid of that fraction, right, it would be to divide by negative 15 sevenths, which is the same thing as multiplying by the reciprocal. So I'm going to multiply by the reciprocal right away. I can put a little 1 under that 3 because 3 as a fraction is 3 over 1. And then I can see those multiplying reciprocals always gets us 1. So we get just that 1x, that x. And here I can do some cross simplifying. 3 goes into 3 once. It goes into 15 5 times. So then I can see, oh, I'm just getting negative 7/5. Well, that's improper. So I can rewrite that 5 goes into 7 twice with 2 left over. So I'm getting this x is negative 2 2/5. Again, I could do this on here. I could just use my calculator. The opposite of multiplying by negative 2 1/7 is dividing by negative 2 1/7. So I could do take my 3. See if I can get this. Oh my gosh, you guys. 3 divided by, I would do negative 2 fraction button 1 fraction button 7. So I'm doing 3 divided by negative 2 1/7 in my calculator. Press enter. Oops. Ooh, I made a mistake. Negative 1 2/5. So good to have the calculator. Yeah. 5 went into 7 once. That was silly of me. So we have negative 1 2/5. All right, you guys try these. Ooh, but before we do, here's an issue. We got this negative off to the side. what do you do with it? On the top of these notes, it tells you if it's off to the side, it's either you put it with the top or you put it with the bottom. You can't put it with both, but it's easier if you put it with the bottom. So when I see this negative off to the side, I'm gonna rethink this. And what I'm really thinking is this is the same thing as x divided by -4. And that's the problem I'm solving. So I'm moving this negative and I'm putting it with the bottom. All right, try this.